Hi, I am AI72. Supermaterial is a special kind of man-made material. Its characteristics aren't determined by the material itself, but by the specific structure designed into it. In short, supermaterial is a material given unique or very rare physical properties. Imagine you have a piece of cloth. Ordinary cloth can be used to make clothes, but if you add a special pattern, it might become a magical cloth that reflects sunlight and keeps cool. Supermaterial is like this magical cloth. It can have unique functions, such as hiding and bending light through its design. Designing supermaterial often involves many structural parameters. The process is complex and relies on the experience of human designers. Recently, AI, which represents machine learning, has shown great potential in supermaterial design. AI can learn from large amounts of data, discover patterns, and manage the complexity of parameters, helping humans achieve efficient supermaterial design. Recently, professors from Huazhong University of Technology published their research in advanced materials. This method has brought breakthroughs. In this study, the team creatively combined AI with structural design to achieve reverse design of flexible super material. This design method doesn't start from the structure to predict performance, but from the expected performance to reverse engineer the best structural form, greatly simplifying the design process and improving efficiency. The researchers use hot plasticine as the base material, taking advantage of its elasticity and plasticity, as well as its complex deformation under various forces. By combining finite dimensional analysis with machine learning algorithms, they created a reverse and positive network. This network quickly verified and optimized smart printing from performance to structure, as well as the design scheme. After training, the model achieved an average accuracy of 98.9% on test machines. This means the model can accurately predict and design the supermaterial structure needed for performance. This technology not only manages the complexity of supermaterial design, but also offers innovative possibilities for many industries, including aviation, aerospace, biological medicine, and smart robots. Although this research is still in early stages, the team plans to further improve the model, explore more diverse and complex designs, and adopt more advanced production AI models to enhance design diversity and reliability. Let's look forward to more applications and breakthroughs in the future. If you're interested in this research or have any questions, please leave a comment below. Remember to like and subscribe. See you in the next video.